All right, happy Wednesday, everybody. Getting into the middle of January here. Welcome to the Cloud Native Coffee Hour. I am your host, Adam Sova, and today on the stream we have Scott Williams, Cloud Native Engineer, with us. And today we're going to be switching it up a little bit. Normally we're talking about um, new tools in the cloud native landscape, or um, our trip to KubeCon a few months ago. We're keeping it pretty cloud native today. We're gonna move on to the development path a little bit, and we're gonna talk about a problem that Scott and I had at a previous employer that we solved using the microservices outbox pattern. And I'm going to kick it over to Scott to provide an overview of the problem we encountered. And, we'll start getting into the details of how we solve that. So go ahead, Scott.
Well, thank you, Adam. And like Adam just said, we're transitioning over from the admin side, more on a cloud native development side. And the thing that I think a lot of developers have seen over the past decade, or 2 decades, depending on how long you've been in industry, we've gone from maybe a company that has one or two monolithic data sources where we had giant Oracle database, we had our giant MySQL database, and by and large, that monolith that ran the company. And some people may think, may hope, well, boy, weren't those the days. But the needs of the enterprise shifted as time went on, and there's demand for more and more data, more and more services, dozens, if not hundreds, of companies. And whether it be by the amount of traffic you had, maybe the amount of scale, or just the amount of domains you were dealing with, you really could not just get by with that one source of data. And so you kind of move out, and and Adam and I experienced this in the many years we've worked together at places we've served at. And you move out and you try and split things into different domains, and we're going to follow the industry patterns. We're going to follow those. We're going to make our microservices, try and decompose things. But what you find there is the standard tool chain you have isn't necessarily going to be enough, because at the end of the day, there's always crossover among your domains. Your order domain, your shipping domain, they need data from one another. And what that came to is, well, the first tool, the first line of attack on that, oh, well, they'll just call each other. Well, it's technically, we're not really doing microservices anymore. We're now bolting things together. We're not loosely coupling anymore. And so that kind of leaves you to the point where, well, now we need some sort of eventing pattern. And this kind of can throw it back to Adam, and that's kind of where we were at Spectrum. How do we do that effectively?
Right. So as we started, getting into the dozens of microservices that we had written, we started, feeling some of the pain of not doing eventing right off the bat. And, as we realized that, we really need an event driven architecture in place, um, we started to move in that direction. We, created, um, a domain of events for systems to be able to communicate to one another asynchronously. And, as we went down this road, we found that we were running into an interesting challenge, and that was, how do we deal with these um, transaction aware situations where we have multiple um, what's the right word I'm looking for?
Dual
So we
right,
have, pardon me.
multiple rights.
Yeah, we have multiple rights to multiple sources. And in our case, we wanted to be able to reliably do a write to a database and kick off a JMS event. And, you know, a two-phase commit was not an option for us. So we, started doing some research, and, that's where Scott came across the Microservices Outbox pattern. And that really helped us. We were able to build some libraries around that and put together a plan for, how are we going to guarantee delivery of these messages? How are we going to make sure that our transactions are reliably written to all sources? How do we not lose events? And I think now is probably a good time to maybe pull up that web page and kind of do a review here of what the outbox pattern does. Um, did you want me to explain that, Scott, or you want to tackle it?
Sure, you go for it.
All right. So in this situation, let's say we have an order service in this example, and the order service needs to be able to write a transaction to the table, and it also needs to be able to send out a message to the message broker saying, hey, a new order was created. So how do we do that in this scenario? Well, what we do is we create a transaction table, some sort of outbox table that we can wrap in a single transaction in the database, so that we can not only write to our order database, but we can also essentially write the contents of the event into an outbox table. And what that allows us to do is it allows us to capture that this order was created, and now we have an event in the database that is an audit of what happened that we will then use in the next step. So once that transaction commits, we know we have that data persisted, and from the first part of this transaction, we are good to go. So the next part of this pattern is, we wrote a library to handle this. You can do this any way you want, but we have a process running that reads from the outbox table and then publishes that JMS message to the broker. And because this process is running separately in reading from that table, we can guarantee that we push this event to the broker at least one time. So the caveat with this is behind excuse me. Behind the scenes, that outbox table has some sort of status on it, where you want to be able to say if this message has been sent or not. Or you can omit that status column and send everything, but then you're sending a bunch of duplicate events. But as long as the JMS transaction commits successfully, we know that the broker has received a copy of the event. Now, if we go to update the table after that transaction commits and that fails, we're going to end up sending that event a second time. But that's okay as long as the consumers know that they need to be able to handle duplicate events. And in our situation, that worked perfectly because we were in control of consuming those events in most cases, and our consumers knew that they need to be able to handle multiple events. So, that really helped solve the problem for us of, hey, I need to reliably commit this to the database and send an event out for anybody, for consumers that are interested, that shows whatever event that is that we were hoping to capture. I don't know. Anything you want to add to that, Scott?
I thought it was very nice, but I'll highlight a few. I think some of the key callouts. You still have your normal and can have your normalized database tables where you properly reduce all that data duplication. But we're now going to have in that outbox area that document structure, that denormalized version of your event, and that's kind of we have hybrid, basically formats of the same set of data in your database, and that can be resisted at first because you're in a database, you want things to be fully normalized, but that really is the trade-off of microservices to begin with. Is we're going to replicate some data so that we can have all of these different physical locations where we are storing things. So I think that's kind of the big hurdle to get around, whether it's JSON, XML, event YAML, anything like that. And that with that second process that we'll emit to the broker, we have a much cleaner separation of concerns. So that code that maybe is saving things down originally only has to worry about that one transaction and doesn't have to try and do a bunch of item potency checks and all these data sources. And the second process that's reading and publishing only has to worry about the publish. And I think we found that it really cleaned our code up and really produced much less anxiety when reviewing truly essential events that had to get there, had to get out. Because when you say eventing in a lot of kind of front end contexts, it's important and sure it's great, but failure kind of means different things when it's just one client and a UI fails to update versus key data failed to get out. So that's what I'd add.
Yeah. And I think one other thing probably worth mentioning here is the format of the event that we would send was consistent between all of our systems, and I forget I forget what we based it off of. It was actually some sort of cloud event structure that we based it off of. Um, but it consisted of the fields in that were like the event type. So what type of event is this? Is this a new order, um, or order created, order updated, order canceled, things along that nature? If we're using the order service here as an example, we also had like the event timestamp, a unique ID for the event. We used a UUID for that, a correlation ID. So if multiple events needed to be correlated together, again, that was a UUID. We also had the payload, which was, in our case, we were representing that as JSON. And, I think there were a couple other fields on there that I'm forgetting to mention, but no matter which system we were using, all of our events contained that same structure. And, that's, we had a document that we produced that we were able to pass along to vendors and other internal consumers of these events so that, you knew what to expect there. So I thought that was worth mentioning. And I notice you have some other tabs pulled up here as well. I don't know if you wanted to dive into some of those or if there's more you want to add on the actual pattern itself.
Absolutely, we can do that. And I think you pretty much got all of the columns there that just off the top of your head. Because we have an our ID for primary key, our correlation ID for route tracing, topic name, so you could do different types
Oh,
of
yeah.
topics.
Yeah.
You said that event type. It's the same.
No, the topic name was
Yeah.
different than the event type. The topic name
Oh,
was um, actually where we were going to place the message, which topic it was going to go on.
okay. Gotcha. And then finally status, and then the temporal columns. And that was nice. But yes, let's move on to our next article. You want to? We can do. Well, let's do Debezium. Let's do Kafka. So, one of the one of definitely the evangelists for this pattern is by a person named Gunnar Morling. You can see on Twitter and other forms of social media, and he works and develops for something called the Debezium project, which is a Kafka Connect project, which is a product you can use to basically sync a data source with Kafka, which is a message broker we have worked with. Not we've had to deal with some older, more legacy message brokers, but that's obviously one of the large ones out there right now. And this is a product you can hook up and configure to just sync your Outbox table. So you don't have to, you're not going through, the 40, 50 tables in your microservice. You're just having to look at that one table, which, I mean, that's a very nice simplicity gain. And that's the nice side of the trade-off of we're going to write down right now in a document format what we want this event to be. Because one of the things you'll see the more you read about Outbox, it is one of the implementations of change data capture, being how do we look at this database and emit the right changes out of it. And there are a lot of different ways to do it, but this is definitely our favorite one. We're reviewing them because most of the other ones, it puts a lot of pressure on the emitting process in the complexity. So this is just the whole ecosystem and one of the off-the-shelf products. If your organization allows that you can bring in, which is quite nice.
Yeah, for sure. So one of the questions that we have from chat here is might be getting to this, so stop me. But are there particular message queue platforms that are required to support this pattern? So you want to go ahead and take that, Scott?
Well, sure. And as long as the platform has an API that you can hook into and commit messages to, this is something you can do, which is great. As long as it has its own concept of you can commit messages on a transaction, that's the beauty of it, because there's no requirement like with XA transactions, which have really they've kind of fallen off in usage, where you're having multiple physical locations be a part of the same actual transaction. Those need to be supported by all the data sources you're using, and like Kafka doesn't do it, really only the legacy JMS vendors do it. And so that's really the advantage of the Outbox. It's two separate physical transactions, but they both become guaranteed eventually for our eventual consistency. So
Right.
it would be nice to make one that make a little code base, little open source download that works on your JMS one to
Yep.
AMQP and Kafka. I don't. That would be nice, because then it would really have that versatility.
Yep. In our situation before, we were, primarily using, AMQ as our broker, and we were using either Oracle or Postgres databases behind the scenes, and this worked really well. Now there's, as you mentioned with like Kafka and Debezium, there are some better ways to do this with less manual pieces to write. But that's one of the nice things about this pattern is it can be, implemented multiple ways and still be very successful. So what else you got up there?
What do we got? What do we have next up? We have the Red Hat side of things, which gets more into our dual write problem. And I like the definition. The indicator that you may have a dual write problem is the need to write to more than one system of record predictably.
You go ahead and zoom in on that a little bit.
Absolutely. What do you think?
Yeah, that looks better. I think the stream will be able to see it a little easier now.
This is kind of I like the little example. What if you have to update a NoSQL database, search index into cache? And I think I like that first bullet point. I think a lot of us, when we think of our single source of truth in a microservice, we're thinking the classics. We're thinking relational databases, and
Yep.
that's fine. SQL runs the world, and even if it's not SQL, it'll have a SQL API. Don't worry about it. But they're actually Debezium has I believe it's a Mongo plugin as well for it. So NoSQL could be your source of truth. You could make an outbox pattern out of that. Look a little different, but it's that same idea. I'm separating my concerns of saving to the source of truth and emitting into my broker. Yeah.
Yeah, and those bullets there, those are several of those are ringing a bell from situations that I've encountered before, and I'm sure you have, and just like we've mentioned, we've had a lot of success with this. It's been very reliable for us, and that's why we want to share this, because one of the things you know typically deploy to a containerized platform, your microservices. There's lots of benefits to microservices, which we could cover in a stream by itself. uh, but this pattern has really been helpful. So we got another question from the chat, Scott. um, so someone has noticed it appears you have a candle lit in the background, and they're interested to know what scent that candle is.
Oh, well, it's actually two candles at once because I like the combination. We have a Santa's cookies candle, which I think should actually just be called brown sugar, and then we also have the Macintosh candle, and I think they synthesize very well.
Fascinating.
Fascinating.
All right, what else you got up there?
Can move. That's the stream. So we have this is more of a transaction patterns, a much older article, more of the different ways to do transactions by one of the Spring Team guys, David Sire, and basically life with and without XA, because in 2009 it was a kind of a bigger deal to go against that. And one of my favorite parts of it is where he gets into the scenario you spoke of, where that last commit goes bad, and you end up with a repeated transaction. And basically, he calls that the best effort single phase commit. And let's see, I should probably distribute it. That's full. Share transaction. It's the next page. And so this is the pattern we talk about. It's non-XA. And the idea is you're going to open up a number of transactions. In this case, we have one open on our emitter for both the database and our JMS or our message broker. And the order you open the transactions up is the reverse order you're going to commit them in. And that is how we get to that at least once delivery. Because we open up our transaction, we grab the one new event, we send it to the broker, and then we're going to commit the broker, then commit the relational database, or it could just be your source of truth database. And that's how we really get that guaranteed delivery. Because, imagine it in another order. I open up my source of truth, I emit to the broker, I then update it as emitted on the source of truth and commit it, and then I try to commit the broker, and the broker throws an exception. And now then you have the doomsday. You have the dropped event. And so that's what I really like about this article. It kind of goes through just the history of that.
Yeah.
Yeah.
Yeah, I think that's a pretty good summary of that, and ways that we've tried to tackle this in the past, that kind of your best effort. um but at some point you start working on systems where best effort isn't good enough. You need to have some sort of guarantee. So um those are situations we were running into that we had to solve for. So, anything else you want to add on this topic?
Um, I would say just in general with microservices and trying to get to that eventual consistency, I think there are a lot of tech and tech adjacent positions where through no fault of their own, things change quickly. There's not exactly an awareness that at a lot of companies, this is how things work now. It's not a magic wonderland where you just synced 30 different things at once. Um, and I think there's a little bit, there's still some cultural, some education that has to happen as part of, company knowledge sets. Um,
Absolutely.
and I mean, take it from me, YouTube, when you have a low traffic YouTube channel, you upload that video, it might not appear right away. That's there's things like that. Not everything gets there immediately. Another one, in some companies, a web service or integration team might design their own schema. There might be places where that is the concern of a different team that builds the schema, and they may want a more traditional style schema and may kind of be shocked at the idea of storing, a denormalized document in their relational database. And again, it's nobody's out to get you. They're likely doing what they think is best for their company. It's got to be a conversation. I'd say, our architects there come in are very important, and it really emphasizes that, the communication and the emotional intelligence side of the technical job.
Right. Yeah. So you touched on a couple good things there. That one, you know, there needs to be awareness around this issue. Not you know, and like you said, that's just an educational thing to you know that hopefully as someone's coming into the industry and getting mentored, that their mentor is teaching them about things like reliability, and making sure that you know you're watching out for some of these pitfalls where you know where a transaction fails and you end up with a lost message, and then you're doing all kinds of support and digging through logs and databases trying to recover it and figure out what happened. um, you know that's one of the nice things. If you do keep some sort of history of your events, you do have something to look back on. Now, when implemented correctly, you should you know be aware if something was sent or wasn't sent. um, but if something's maybe off, not implemented correctly, to still have that event in the system, saves you a lot of time and support. um, so awareness is really a good call out there. You know I, I've seen that in my 20 plus years in the industry. And working at multiple places, this isn't something that people are always thinking about. So you definitely have to be on the lookout for it, just kind of like how you look out for SQL injection and things like that we've become trained to notice. There are other areas like this that are just as important and critical.
I like that. Yeah, look at the old messages, even if you have to replay something, because
Yep.
Kafka stores all the messages. And yeah, obviously you're gonna have some sort of compaction or some sort of deletion strategy. But when we worked on our more legacy JMS brokers, they're more ephemeral. So if all the consumers have consumed that message, that's getting deleted, and this gives you an option to keep that log on the source of truth. Now that might get deleted someday due to space concerns, but it's another option.
Yeah. So I think we're getting to the end of the topic that we had prepared today. One of the things I want to mention, though, is that Scott and I are working on a little code base to demonstrate, uh, how this pattern works. Put some code out there, and we're gonna put it out there in a library form, so that once we feel it's hardened, we can release it to the community and let folks that want to use it, take a shot at it and get some feedback there, and make it something that folks can leverage, and we can make it adaptable to different types of brokers. Kafka integration, AMQ integration, uh, to name a couple. And so that's something that we will eventually be releasing to the devs operative GitHub repository. So keep an eye out for that. And any other closing thoughts, Scott, before we wrap up?
I don't think so.
All right. Well, we thank you guys for being with us on the stream, and we look forward to next week. Not sure what the topic is off the top of my head, but next Wednesday, same time, same place. Everybody have a great week.